Hey everybody, welcome to your first online lecture video. First we're going to be talking about building site conditions. The sun, as our main source of energy on the planet, influences the way the building is positioned on the site and the size and location of windows, skylights, the lighting design, and the amount of heating and cooling needed. Sunlight not only helps light our interiors, but it also contributes to the deterioration of paints, roofing, wood, and other building materials. Like here you can see the sun that has come in from this window, hit this rug, and faded the floor all the way around the perimeter of the rug. So fabric dyes may fade, wood stains may fade, plastics. So as an interior designer, you must consider that when specifying materials. Many things affect how sunlight reaches your building site. Distance from the equator is one of them. The altitude of the site, the proximity of the site to water, and the presence of shade trees and other large features. In northern latitudes, further away from the equator, the sun is more perpendicular to the earth. So you can see here that it's rotating more even with the sides of the house. In southern latitudes, the sun angles are more directly above the earth. In cold climates, structures focus on heat retention, protection from the rain, snow, and cold winter winds. Passive solar heating, minimizing surface area to help reduce exposure to cold temperatures, and orienting the building to the south to take advantage of the sun are ways to keep the structure warm without mechanical assistance. And here you can say they want you to insulate very heavily. In this drawing, the house is positioned on a hill, and you can see this is a south-facing hill. So the main portion of the house faces the south, and then it has this hill and these trees in the back to help insulate it from winds that come down from the north. And then here, this double glass area, these large windows, the solarium, help bring in the sun's heat. This very thick floor helps insulate the bottom near the ground. Oh, and look here, skylights that help bring in more sunlight. In temperate climates, buildings will typically require heating in the winter and cooling in the summer. Temperate climates are most of the United States. So south-facing walls should be maximized again, but with shade covering the east and west exposures. Building orientation and landscaping can create the shade, while window locations can aid in ventilation. Trees that lose their leaves are great in temperate climates because, as you can see in the summer, when the sun is hot, the tree works to shade the majority of the house, and then they lose their leaves in the winter when you want more heat from the sun and there's less shade on the structure. In hot, arid climates like Arizona, buildings should take advantage of wind and rain for cooling and adding humidity. If you remember, we talked about the concept of a swamp cooler, or a water feature basically in the house that evaporatively cools the air around. And here you can see in this particular house, this large eave or projecting roof shades the area around. Also, the light colors that are used help reflect the sun's rays and don't absorb heat. In hot, humid climates like here, buildings should be shaded from the sun and take advantage of breezes for cooling. East and west exposures are minimized, and windows are designed so they can remain open as much as possible. That's why you see this big screened-in porch here, so that windows can stay open, but all of this nice air and breezes can come in. Also, all of these plants surrounding the house help shade it and cool the air through evaporative cooling as well. Many times in these southern houses or houses in hot, humid climates, they raise the floor above the ground and create this crawl space, which is a way to continue to circulate the air. So multi-story buildings are often designed in layers, as you can see here in this image. The sky layer, obviously the top layer, is isolated from a lot of the activity below and has a lot of is affected more by wind and rain and sun and that sort of thing. but it has better views, more privacy, and usually less noise from the ground area below. The near surface layer is a little bit more accessible by activities, still has more increased privacy in some views, and a little bit less noise. The surface layer is the most active and most accessible to people and activities, has the most public contact, but is also closest to many of the sources of noise. And the subsurface layer is the most quiet, provides the most thermal protection, but could be susceptible to water. Sustainable buildings are designed to be sensitive to the surrounding climate. And the climate of a site is determined by many various features, as you see here on the screen. The sun's angle and path, air temperature, the humidity level in the air, the amount of precipitation a region gets, air motion or the amount of wind, air quality or pollution, characteristics of the ground surface like landscaping, and also the density of the soil, the wet moisture in the soil, and the topography of the site, including hills, mountains, elevation, that sort of thing. The interior of the building responds to these surrounding conditions by opening up or turning away from the views, noises, smells, and other disturbances. So if you have a beautiful view outside, perhaps that aspect of the building is open and has many windows. If you have a parking lot next to the building, maybe there are fewer windows on that side. Fresh air and sunlight from the outside help to improve the overall health of a building's inhabitants, and many offices are now realizing that the more daylighting, the more sunlight that comes in their building, the more interior plants they have, the more productive their employees are. Plants help your building in other ways as well. They increase the humidity of the air and lower the site temperature. Large bodies of water and plants help moderate air temperatures, and the water is usually warmer than the land in the winter and cooler than the land in the summer. So it helps warm the air in the winter and cool the air in the summer. The absorbency of the landscaping will determine how much heat is reflected from the land to the structure. A rocky landscaping in a hot climate, like you see here, will heat the nearby structure, whereas grass will help cool it by absorbing solar radiation and cooling the air via evaporation. There's a big argument in Arizona about having desert landscaping near buildings because it reduces the amount of water needed, and water is very scarce in the desert. But there's a lot of energy spent on cooling the interiors in the desert in the summer, and grass helps bring down the temperature of the building. So it's kind of up for debate. Do we save on energy costs or do we save on water? So plants also will clean the air in addition to wind protection, shade, noise reduction, and air temperature maintenance. So when you're choosing plants for your project's landscape, or if this is something you do as a designer, consider their shape, their density, the density of their leaves, how large they are when they mature, how long they will take to grow, and how they're going to affect then all of these features that we just discussed. Lower maintenance and native plant species tend to have the most chance to survive of all. Winds are usually weakest in the morning and strongest in the afternoon. Plants and outdoor structures like walls and statues and features can deflect wind, which is great in the winter, but you also want to consider if that's something that you want to happen in the summer when maybe you need that breeze. Water will hit your site in several forms. Precipitation, groundwater. This is an example of something called the hydrologic cycle, and you can see that here water that exists in the lakes and the oceans evaporates into the air, turns into clouds or condensation, which then rain or snow onto the earth, runs off, and then collects in groundwater, and then flows back into the streams and the ocean. So in addition to precipitation, the groundwater, the amount of groundwater, the availability of groundwater will also affect your building site. potable water, which is drinking water, clean water, and also finally wastewater. So how do you rid the building of waste, and how do you take that water and get it to where it needs to go to be treated? Architects, landscape architects, and interior designers can incorporate methods to collect rainwater, reduce water use, and recycle water for use in landscaping. So that's it for this video. Next, watch Designing for Building Functions.